this is pretty much it. I'm going to give you some more problems, type of related rates problems, but this is pretty much it. It's just related rates and implicit differentiation for this unit. All right, so let's look at this problem here. You've got a particle moving along a parabola, and here's your parabola. It's a y squared equals 6x parabola. It's a y squared parabola. So it's actually, I think it's a parabola that looks something like this. I don't actually know exactly what it looks like, but it passes through the point 77. Okay, its y coordinate is increasing at a rate of, okay, let's just think about what we have here. Talk calculus talk. Even if I drew this picture wrong, okay, all of my equations and my points can be substituted into a wrong picture. It's fine. All right, so I've got the y coordinate is increasing at a rate of, what is that in calculus talk? Calculus talk. dy dx, no, dy dt, right? It's increasing, so that's going to be plus 3 units per second. So everybody good with that? I need to get the calculus talk in, okay? How fast is the x-coordinate changing at this instant, okay? So as it passes through 0.77, so I've got a point. Guys, what does this point tell me, actually? Does that make sense that x is equal to 7 and y is equal to 7? And is this particle that's moving in this parabola, so what's happening is it's kind of like you're walking on this path, okay? The particle is walking on this path. Is it always at 7,7? No, so 7,7 is a moment in time. So let me just put moment in time there. That means I can only use it after I take the derivative, okay? What am I trying to find? It says, how fast is the x-coordinate changing at this instant? So what am I trying to find? dx dt. Okay, so look, I'm trying to find dx dt when x is 7 and y is 7. That's a moment in time. It's not always true. I'm not always standing there at 7, 7. I'm moving actually along this path, okay? And I'm trying to find dx dt at that moment in time. All right, so here we go. We got a picture. We got x. We've got y. What is my equation? What is my equation? It's a parabola. It's got x. It's got y. Guys, do you see sometimes they give you the equation? Does that make sense? Anytime it's a path, like on a parabola, on a circle, whatever, they give you the equation. The equation is right there. Do you have an equation that ties your y and your x's? It's right there. Okay, is everybody good? You should be happy about that. All right, so once I get the equation, what do I do with the equation in related rates problems? What do I need to do? Take the ddt of both sides. So I'm going to do the ddt on this side and the ddt on that side. Okay, what's the derivative of y squared? 2y. What's the derivative? Oh, wait. Do I need a dy dt? Yes. Okay. What's the derivative? I'm going to kind of like cannibalize this picture. What's the derivative of 6x? 6. Do I need a dx dt? Yes. What's the derivative of 7? 0. Okay. All right. So what I have is 2y dy dt equals 6 times dx dt. And really, I just plug in 2, because I've already taken the derivative, right? Once you take the derivative, you can put in the moment in time. So 2 times y, do I know what my y is? 7. Do I know what my dy dt is? 3 equals 6 times, do I know what my dx dt is? No, but isn't that what I'm trying to find? So I'm pretty much home free here. This is 2 times 7 times 3, which is 14 times 3, which is that 42, guys? 42 is equal to 6 dx dt. So therefore, dx dt is equal to 7. Okay? I need to get my units. X, what is my units for x? It's some sort of length. It's just units. Everybody good with that? So units for x is just units. What is my units for t, which is just time? Do you see it? Seconds, and I'm done. The answer is 7 units per second. These are actually the easiest questions to do whenever it's just an equation that you just have to take the derivative of both sides. You never have to like figure out what the volume is or the area or anything like that. All right, here's another problem. This is a little bit tougher. Whenever you guys draw pictures, it's easiest if you do draw pictures of distances, just FYI. So distances are easier because when you take the derivative, then it becomes the velocity. Okay, you have two cars, okay? They're moving, how do I move this thing? There it is. They're moving from the same point. One is going south and the other is going west. Okay, so we've got to draw this picture. One's going south, so that's south, and the other's going west. They start at the same point, so it's got to look like this, okay? One is going south at 25 miles per hour. So I'm going to call this X and this Y. And X's and Y's are distances, guys. So let's just make sure you understand. It's much easier if you make these distances. If these are distances, then the one going south at 25 miles per hour, what would that be in calculus talk if this is called Y? Does that make sense? Because then the rate would be 25 miles per hour, okay? When you talk about velocity, it's really just the derivative, basically, of distance, okay? So the velocity is the derivative of distance, and the distance is y, okay? The other travels west at 15 miles per hour. So in calculus, guys, calculus talk, what is 15 miles per hour? dx dt. So dx dt equals 15. Now I'm going to write this miles per hour like this so that we can see that it's really just a fraction, miles over hour. At what rate is the distance between the cars increasing 2 hours later? So what are they asking me for? The rate between the two cars. Well, you guys agree that this right here is the distance between the two cars, right? So let's just call that, do you want to call it h for hypotenuse? You guys okay with that? Okay, so I'm trying to find, if this makes sense, dh dt, okay? But not right now, at a moment in time. At a moment in time, when time equals 2. Okay, is everybody good so far? Okay, so I've got my picture. Do you see it's a right triangle? I've got x, y's, and h's. Guys, any idea what my formula is going to be? Yeah, it's going to be the Pythagorean theorem. X squared plus y squared equals h squared. Now, here's a question for you. Does any one of these stay constant? Because remember in the ladder problem, when we did the ladder problem, and the ladder fell down, that ladder stayed 13. Does that make sense? And we just kept a 13 in here. When the car is moving this way, another car is moving this way, is h always changing? The distance between the two cars? Yeah. So do you guys see, in this situation, I can't call anything a 13. Does that make sense? I can't change it to a number. But if I could, I would, because the derivative of 13 is 0, so it's way easier. Okay, so what do I do after I get the equation, guys? Yep, take the derivative of both sides. So what's the derivative of x squared? 2x dx dt. What's the derivative of y squared? 2y dy dt. What's the derivative of h squared? 2h dh dt. Okay, you guys good with the derivative? And now it's just a plug-in, okay? Now the plug-in's a little bit, it takes a little bit of work, and let me show you why, okay? Now this is already taken the derivative. It's done, so I can push in the moment in time. You guys good with that? So here's a question. 2 times x. Do I know what x is at a moment in time? I don't. Does that make sense? I don't know like what this distance is right here, and I don't know what this distance is at a moment in time. Or do I? Well, right here was time equals 0, right? Right here is time equals 2. So what is the distance I traveled from time 0 to time 2? How do I find that distance? If I know that the one going south is going 25 miles per hour, okay? So if you're going 25 miles per hour, how much distance have you traveled 2 hours later? 50. So this is actually, and I'm not going to draw on this triangle because this one changes, but I'm going to make myself a moment in time triangle. And in the moment in time triangle, this one's 50, okay? And again, if this is time equals 0 and this is time equals 2, what's the distance of your x after 2 hours? If I'm going 15 miles per hour, 30, right? Guys, if you know this is 30 and this is 50, then inside here, and I am not sure what this is, but it's 900 plus 2500, right? It's a square root. If you do Pythagorean theorem, it's 900 plus 2500. So I think that's the square root of 36. Is that right? I actually don't know. 34? 34. So this would be the square root of 3,400. And that's the square root of 34 times the square root of 100, right? So that's actually 10 times the square root of 34. Okay, you don't have to change it to 10 times square root of 34 if you don't. You could just keep square root of 3,400. But that's what this is. So guys, at a moment in time, I've got this distance is 30, the x, the y is 50, and then do you see the h is 10 times the square root of 34, or the square root of 3,400, however you want to say it. Okay, so I'm going to plug in now. Now I'm ready to plug in. 2 times x, what is my x? 2 times, is it 30? Do I know dx dt? Okay, 15 plus 2 times y. Okay, what's my y? 50. Do I know dy dt? Is it 25? Okay, equals 2 times h. Do I know my h? That's the square root of 3,400, right? So that's going to be 10 times the square root of 34. And again, if you want to put it in the square root of 3,400, that's totally fine. It will still work out. And I'm trying to find dh dt. So I'm basically done. This is my equation. It's just algebra equation that I need to solve for. Okay, just be careful here, guys. Let's just talk about our negative signs and make sure they're right or wrong. This y length, is this y length increasing or decreasing? The y length. It's increasing. So this dy dt should be positive. Does that make sense? The x length, is it increasing or decreasing? It's increasing. So this dx dt must be positive. There are situations where if one is decreasing, does that make sense? This would be different signs, so you get a different answer. Okay, so just be careful. Make sure your lengths are really increasing if you're saying the rate is positive. All right, so let me go ahead and figure this out. You could actually divide everything by 2. Divide by 2, divide by 2, divide by 2, both sides. And so this becomes 30 times 15, which is 450, plus 50 times 25. I'm about to reach the limit here of my math. 0, 5, 2, 1250 is equal to 10 square root of 34 dh dt. I could divide everything by 10. Divide by 10, divide by 10, divide by 10. So I get 45 plus 125, which is 170 over square root of 34. Okay, but if you have a calculator, you could do it that way too. I don't know if this is right. I think it is. What did you guys get for dh dt? Go 3 decimal places. You got that? Good. What did you get for decimal wise? 29 point what again? Okay. So remember, you can truncate or you can round correctly, but you have to have at least 3 decimal places. Let's talk about units, guys. What's the unit for h? H is a length, right? So go find a length unit. Is it miles? And then what's the unit for time? We need to go find a times unit, hours. So this will be miles per hour. Actually, that makes sense that this is miles per hour. Okay. Any questions about this type of problem? Okay, so you'll see that on your homework tonight also. I want to go ahead and do this one. This is actually, I was going to talk to you about it tomorrow, but you have it on your homework anyway tonight. So I'm going to go ahead and help you guys out with this. You have a cylindrical tank with a radius of 4 inches. Okay, so let's just draw this tank. This tank, it's cylindrical, has a radius of 4 inches. Okay. There's oil in it, and the oil is leaking. Okay, so let me put some oil in this tank. Okay, I'm going to call that level of oil H. Okay, so there's oil in it, and the oil is leaking. Okay, the height of the oil is dropping, so I'm going to call that H because I know this H is changing. The height of the oil is dropping at a rate of 0.5 inches per second. So what is that in calculus talk? Are you guys good? That's calculus talk. Okay, but here's a question for you. Is H getting smaller or is H getting bigger? Smaller. So I'm going to put a negative there. Okay, and once again, most of the time it doesn't matter if you get the sign wrong, you'll still get the magnitude right, but sometimes you'll get the magnitude wrong. So I try to do the signs right whenever I can. Okay, find the rate at which the volume of oil is changing. Okay, so what am I trying to find if I'm saying the rate at which volume is changing. What am I trying to find in calculus talk? D what? dV dt is question mark. When the height is 6 inches, so the height when h equals 6, is h always equal to 6? No, h is changing, so I'm going to put moment in time there. Okay, that means don't use it until after I take the derivative. Okay, I can't emphasize that enough, because what happens is students use these numbers inside when they're making their formula, and then it's all wrong. Okay, because the derivative of 6 would just be 0. Like you'll get a number. All right, so let's see what I have. I've got V, I've got H, I've got a cylinder. What's my formula going to be? It's the volume of a cylinder, right? Anybody remember what the volume of a cylinder is? V equals, it's really the area of the bottom times the height. So the area of the bottom is just pi r squared, right? And then it's times the height. Okay, I'm going to take the derivative of both sides, the d dt, but I'm going to pause here. Okay, guys, remember in a cone, we could get rid of one of these by doing similar triangles. Okay, the sad part is students try to do the same on this one, and it's not. Guys, do you have similar triangles anywhere here? There's no triangle. If anything, you might have rectangles, okay, but there's no triangles, okay? So I'm going to tell you the trick to this problem. And I want to say the BC students took their test, and I guess those who really understood it, did this problem right. But those who didn't look over their homework forgot that the trick to this problem is that the radius never changes. Do you agree? Think of how that oil drops down. Does that radius ever change as the oil drops down? No, the height changes, but the radius doesn't change. So guys, what's the radius in this problem? 4. So what's 4 squared? 16. So before you take the derivative, just change this to a 16. And that is a trick to this problem. This makes this problem so easy. But if you start trying to do similar triangles, and it's not a cone problem, so it's not a similar triangles problem, and there are no triangles in this picture, then you're going to spend a lot of time just not getting the right answer, okay? Guys, once I get here, do you see how easy this is to take the derivative? Like with H's and R's, that was so hard. But guys, what's the derivative of V? dV dt. What's the derivative of 16 pi h? 16 pi, but don't forget, dH dt. And look how easy this is. What am I trying to solve for? dV dt. Okay, do I know what dH dt is? Negative 0.5, right? So this actually, because that's really just 1/2, this becomes negative 8 pi. Okay, and guys, I always welcome having pi's like staying in the answer. If you want, you could put it in your calculator, but why? If you put it in your calculator, now you have an inexact answer, okay? Multiplying by pi is the exact answer, okay? Let's look at units in this problem. What's the units for volume? Go find a length and make it into a volume. Okay, so what length do I have here? Inches, but how do you make inches into a volume? Cubit, okay? I need a times on the bottom. What's a unit for time? Seconds, okay? And that's my answer, negative 8 pi inches cubed per second. So let's think about this. This is saying the volume is decreasing, right? It's negative. Is the volume decreasing? Yes, check, okay? And that's how you do this problem. The last problem I'll do with you guys tomorrow. Let's talk about problems you have questions on. Mm-hmm. Uh-huh. There was like a point where you had to multiply with pi, right? There are some problems like that, yeah. So, yeah, just try one way. If it doesn't, then try it the other way. On the test, remember, I'm looking at your answers, so you're fine on the test. I can tell. As long as you go 3 decimal places, you're fine. Or if you leave the pi in, then you're good. Now, here's the problem that, because BC just took the related rates test. Here's a problem that students have, though. Instead of writing negative 8 pi, they'll put the answer as negative 8. Now, that's a problem. Does that make sense? But if you multiply by pi, or if you leave the pi in, I'm good with either way. Okay, so remember on your test, I'm grading your actual work. Okay, let's look at homework from last night. Can we answer problems that you had questions with? I know that isosceles triangle question gave you guys some trouble, right? You want to do that one? Okay, I don't know what number that one that was. 9, okay. The isosceles triangle looked like this. And the first one, can you tell me what you're trying to find? I actually don't know what you're trying to find. Was it like a rate? Okay. Okay. At what rate was the area of the triangle changing? Okay. So when the leg was 1 meter long, is that what it was? Okay. All right. So this is Karina's problem. Yours is probably something similar to this with different numbers. Okay. So you've got an isosceles triangle. You have to know what an isosceles triangle is. It's a triangle. It's a right triangle. It's an isosceles right triangle. So it's a right triangle. But since it's isosceles, you have two legs that have the same are the same length. So it's L and L. You can call X and X too, whatever you want to do. Okay. They give you the change in the length is 2, and you're trying to find the change in area when L is 1. And this is a moment in time. L isn't always 1. Okay. All right. So let's think about the equation. I've got an area, and I've got L, and I've got a triangle. Okay. So what is the equation that I'm working with here? Just area of a triangle, right? So isn't the area of this triangle base times height divided by 2, right? Or maybe it's easier to say 1/2 times BH. That helps you with fractions. If you bounce the BH out, that'll help you if B or H are fractions. What's my base in this problem? L. What's my height in this problem? L. You guys good with that? So my formula is going to be A equals 1/2 L squared. That's my formula. Okay? So first you draw the picture. Then you do your calculus talk. Okay? Then you do what? Then you take the derivative of both sides. What's the derivative of A? Isn't it just 1? But don't forget, dA dt. Okay? What's the derivative of 1/2? Like, what if I had 1/2 x squared here? How would you do the derivative of that? 2 times 1/2, which would be 2 over 2, right? Then you carry down the x and take it down by 1 power. Okay, that's L to the 1. And then don't forget to take the derivative of L. Okay, but that's the same as dL dt. We're really just doing chain rule. Anytime we do implicit differentiation, it really is just chain rule. Okay, everybody good so far? And from here, it's really just a plug-in. You're trying to find dA dt, right? 2 over 2 is just 1. What's my L equal to? Here, can I plug in a moment in time yet? Did I take the derivative already? Yes, so I can plug in a moment in time. What's my dL dt? Isn't that 2? So the area, this answer is 2. And then let's get units here. Go find a length and then just square it. That's what area is, right? I think you said meters, I'm not sure. Okay, then that'd be meters squared. And I need a unit for time. And I don't know what the unit for time is, but go find seconds. And so go find a times unit and copy it down. Okay. The second one, instead of giving you a leg, they gave you a hypotenuse, I think, right? So really the same problem. What was the hypotenuse that you had? Okay, 4 meters. So it's the same problem, right? I think they're asking you for dA dt still. Okay, so it starts out the same, okay? Everything here is the same. The only thing that changes is, okay, you've got the formula A equals 1/2 L squared. You're going to take the derivative of both sides, so dA dt equals 2 over 2 L dL dt. Actually, it's really the same. Now you're going to plug in. This 2 over 2 turns to 1, so don't worry about that. But instead of L, the problem is you don't know what L is. Or do you? Well, let's see. You're going to do dA dt is equal to L times, what's dL dt? I think you still use this 1 up here. I still think that's 1. But here's the thing. Do you know L at a moment in time? Well, if the H is 4, let's do a moment in time picture. I don't want to mess up this picture. This isn't a moment in time picture. But if the H is 4, do I know what L is? How do you figure out L if this is 4? Guys, how do you figure out the length of a right triangle when you know the hypotenuse? Isn't L squared plus L squared equal to 4 squared? Right? Pythagorean theorem? And wouldn't that say 2L squared is equal to 16? And wouldn't that mean L squared is equal to 8? It's actually plus or minus 8. But L we've defined as a length, right? So L can't be negative 8. And so L is going to be the square root of 8, which is 2 square root of 2. But I think you could just leave it square root of 8. I think square root of 8 is just fine here. Because then down here, oh, you just plug in L. So this is actually square root of 8 times 1, which is square root of 8. Okay. I don't know if my math labs wants you to change it. Did you guys say something online?
Isn't your DLDT 2 not 1?
Oh, what's DLDT? Is it 2? Oh, yeah, you're right. Thank you. Sorry about that. I don't know where I pulled the 1 from. Oh, I pulled the L. I'm sorry. You're right. This is 2. So this actually here is L times 2, which is square root of 8 times 2, 2 times square root of 8. But the square root of 8 is really the square root of 4 times the square root of 2, right? So that's actually 2 times 2, which is 4 times the square root of 2. That's my answer. And then I need units for area. So again, that was inches squared. And divided by units for time, which you told me was seconds, and I should be done. Okay. Did you like that? It's not too terrible, okay? The hardest part about this is when you came down here, you didn't know what your L was. So you had to go find it. And so you draw another picture called a moment in time picture, okay? And then that's when you find all the things that you need to find that you didn't have, okay? What other questions do you guys have from homework? Let's call them out.
Ms. Chang, could
Yes.
you go over those two that I was asking you about, number 6B?
Can you tell me the problem?
Yes. Do you want me to read it out?
Yes.
Okay. 6 foot tall women.
Oh, it's the lamppost one.
Yeah, it's
Okay.
the lamppost one.
Okay, so the woman is 6 feet tall. Go ahead.
Walking, or 4 feet per second walking toward a street light.
Okay, so dx/dt equals 4 feet per second. Okay.
And 24, and the lamp, or the street light is 24 feet above the ground.
Okay, and that's all we have?
No, the rate of change of the length of her shadow is 20 feet from the street lamp. Or wait, wrong part. At what rate is the tip of her shadow moving when she's 20 feet from the street light?
Okay, so we're trying to find dw dt when x equals 20. Is that right?
I think so. In the tip, it was the tip part.
Oh, the tip part they having questions with? Okay.
Yes.
So, yeah, reread that whole question again, Paige, and let me make sure I have it right, and then I'll start it.
Okay. A 6 foot tall woman walks at 4 feet per second toward a street light that is 24 feet above the ground. What is the rate of, wrong part. At what rate is the tip of her shadow moving when she is 20 feet from the street light?
Okay, got it.
Okay.
So you want to know the d tip, dt equals question.
Yes, ma'am.
Okay. All right, guys. This thing is definitely on your test, so let's make sure you know how to do this problem. Okay, so you got this woman, okay? And not to be sexist, because it could be a woman or a man, doesn't matter, okay? And not to be sexist around directions either. It actually doesn't matter if she's walking left or right, okay? The x is always this distance right here. The shadow is always this right here. So let's just make that clear, okay? Wherever the light is, okay, the shadow is always, the x is always between the light and the person, and then the shadow is always like this tip part, all right? Then you always need lengths for this and this. Well, actually, I guess they could give you different parts, but usually they give you this and this, the height of the woman and the height of the lamppost, okay? This is always a similar triangles problem. It is never a Pythagorean theorem problem. So let me write this. Never a Pythagorean theorem problem, okay? What students do wrong here is they make it a Pythagorean theorem problem and it's not, okay? Do you guys see the two triangles here? So one is going to be 6 and W, and the other is going to be 24. And be careful, this is not 24 and X. What is this big triangle here? What is the length of the big triangle? Do you guys see it's 24 and W plus X? So big mistake that students make is they call this one 6 and W and 24 and X, but it's not. It's 24 and W plus X. Is everybody good with the W plus X? Okay, so this is similar triangle. So, you know, there are lots of ways you can write this. I just go 6 is to 24 as W is to W plus X. Okay, but there are lots of ways you can write this. And what I get is one fraction on the left, one fraction on the right, and an equal sign in the middle. Students get stuck right here because what we need to do is take the dt of both sides. And do you see, I totally see why you get stuck, because nobody would want to take a quotient rule of this, okay? But the trick to this problem, and you guys need to know these problems so well enough, you know the tricks to each problem, okay? The trick to this problem is before you take the derivative, do the cross multiplication. And so what I'll get is 24w is equal to, now be careful, what a lot of people do is they say this is 6w plus 6 plus x. They'll say this is 6w plus x, which is wrong. Do you guys see why this is not 6w plus x? Let me pull this down. Why is this wrong? Don't you just multiply 6 times w plus x? Isn't 6 times w plus x 6w plus x? No, because you just broke up this family. Look at this family, this perfectly good family you broke up, okay? It's actually 6w plus 6x, okay? Then what you want to do is you could take the derivative right here, which is actually really easy to do, but it's actually easier if you do what? Do you guys see it? One more step, it'll make things even easier. Subtract, yeah, subtract the 6w from both sides. So what I'll get is 18w is equal to 6x, okay? And then you take the derivative of both sides. So if I take the derivative of 18w, okay, and I gotta tell you, I can't tell you how many students even stop here, because I feel like, man, you've done like the biggest, hardest part, and now I still can't give you credit. You know why I can't give you credit? Because you still haven't done the calculus, okay? So once you come here, remember to do the calculus. What's the derivative of 18w? 18, but don't forget dw dt. What's the derivative of 6x? 6, but don't forget dx dt. And then here you just plug in. A lot of times they want you to find the shadow, and they give you the rate of the woman or the man. The dx dt, if you've done physics, you know, that's like your x prime or your position prime, your velocity. Does that make sense? The change in position. So they tell us the rate of the woman, I think it was 4. Okay, they tell us that was 4. So what I know is dw dt is equal to 6 times 4 divided by 18. So let me put that here. dw dt is equal to 6, so 24 basically, divided by 18. Let me simplify that. Divide by 6, so that's 4. Divide by 6, so that's 3. Okay, let's think positive and negative. The woman was actually walking. This is the x distance. The woman was walking toward the lamppost. Now, once again, guys, this is always x. You guys good? Whether she walks away from the lamppost or towards the lamppost, this is always x. But sometimes dx dt is positive or negative, depending on, is this length getting shorter or longer? So guys, if she's walking towards the lamppost, is dx dt going to be positive or negative? Is this distance getting shorter or longer? Do you guys see this distance is shorter, right? So the dx dt should be negative. So this should be a negative 4. So then the dw dt is actually a negative 4/3. Okay? So that's the answer for the rate of the shadow. The next question is what's the rate of the tip of the shadow? And so the trick here is to know that the tip of the shadow actually changes with this whole length, okay? As this woman walks, what happens is this thing gets like this, like the length is still, let me see, the lamppost is still like this, but then as she walks closer, see if this makes sense. As she walks closer, do you see how W decreases and X decreases too? Does that make sense? So as W and X decreases, this right here is actually how much the tip decreases. Okay, the tip decreases with the W plus X. So the answer is the D tip, the rate that the tip changes is actually the rate that the W changes plus the rate that the X changes. And so I guess that's just something you have to memorize. It really is just derivative properties, just like we talked about limit properties, because tip is equal to W plus X. So because of that, you just take the derivative of each component. So that means the derivative of the tip is equal to the derivative of the W plus derivative of the X. Okay. I mean, that's basically the reason behind it, but you could just memorize, just add these two together. We already, we found dw dt, right? Isn't dw dt, was it negative 4/3? So this was actually negative 4/3. What is dx dt? Was it negative 4? Does that make sense? So you just add these together, and that's the rate of the tip. So the rate of the shadow is this whole long formula you do. Once you get the rate of the shadow, you just add it with the rate of the woman walking, and that's going to be the rate of the tip. So I don't know how Math Lab wanted you to do this, but what you would do, I think this is just 4 4/3 really, right? Which is really 5 1/3. They probably wanted, I don't know if they took that or if you wanted that. Does that make sense? These are all the same fractions, or even if you put it into your calculator and went 3 decimal places, if you got close that way, whatever they said to do. Okay.
My math lab did not take any of those.
What did it take?
None, like none. Like I did the question like 3 times correctly, and I made sure I did it correctly.
the
And
one
it just
you're
wouldn't
doing?
take it for number 6.
Oh.
Yeah.
What did it say the answer was?
Like whatever
Yeah,
the
that's
answer
what I was
was,
saying too, Miss
whatever the
Jane.
answer was, like I got it correctly. Like I did it in like multiple ways. But like when I did the correct the question
Math
without
is the same, right?
without the help, it just wouldn't work.
Oh, really? So but the dWdt was right, not the tip. Is that correct? Did you get did they ask for the dWdt?
I mean, both the answers work for me when I combine it.
Was the WDT right though? Did you get these same numbers though? Oh, you had different numbers. Do you have your numbers with you right now? Okay, so let me just give you guys a big hint. I'm not going to ask you for the tip on the test, but I will ask you for the WDT. So make sure you can do the WDT. Skylar, can I get your numbers and let me see if I can work your numbers? Do you have yours by any chance? Okay. Or Thomas, were you the one asking online? Who was it? I wasn't sure who was. Mel? I don't know who it was online. I can do your numbers and let's see. Let's see what we get. And you got neither of those using this method. Oh, that's kind of sad. Okay, let me do your problem though. So can I do someone's problem that had trouble? Okay, the woman's 5 feet tall.
The street light is 25 feet.
Okay, street light 25. And then you had to find dWdt, right? Okay, so were you given dx dt, the rate that the woman was walking?
No, it just said
When she was 20 feet from the street light, so that's x equals 20. You need one more thing.
Oh, 6 feet. Or walk 6 feet towards the street line.
6 feet?
Perfect.
Yeah, okay. So dx dt is, here, I'm not going to worry about negative and positive, but it's 6 feet per second, right? Okay, so dx dt is 6. And the question is, this is my x, and my x is 20, right? So this would be, this is my w, this is my x. So 5 is the w, as 5 is the w, as 25 is the w plus x. So if I cross multiply, I'll get 25w equals 5w plus 5x. So that's 20w is equal to 5x. Okay, I'm going to take the derivative of both sides. So that's going to be 20 dw dt is equal to 5 dx dt. Okay, so the dx dt I know is 6. So that means dw dt is equal to 6 times 5 divided by 20, which is 30 divided by 20, which is 3/2. So that's what dWdt is. Did you get 3/2?
Yeah, you just have to like, put it as negative.
Negative, yeah, so it should be negative. So it did work out.
Well, yeah.
Okay.
You just had to like put it as a whole number, so like whole.
Oh, you're saying you had to put a decimal. Yeah, so that's, yeah, it's just picky that way. Yeah, so do you see why it's negative though? Because this distance is decreasing. So technically we should have put a negative here. And if this is a negative, then this is a negative right here. So this would have been a negative, 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 and that's why it's negative.
I just remember
Okay.
you saying on the video that if it doesn't take the positive.
Try the other one. Yes. Okay. Skylar, do you want me to do yours?
I don't know if we can pull it off.
Okay, you're good. All right, so yeah, at least the dWdt should work out, okay? And remember, I'm grading your work, so if you have a 1.5 rather than 3/2, lucky for you, I know what that is, okay? All right, what other questions are you guys having trouble with?
I had one more, Miss Ching, if no one has one.
All right, was that V talking?
No, it's Paige.
Oh, hey, Paige, which other question did you have trouble with?
It was the number 8.
Number 8, okay, which one were you talking about, Megan?
I was talking about 10. Like I got it right, but I don't know
Oh, okay, we're gonna do number 10 first, and then we'll go back to number 8. What was 10?
how. The point is moving on the graph x, y equals 35.
Oh, okay,
It's 75.
and what's 75?
The point is 75.
Okay, 7.5. All right. And then do you know any rate, dx dt or dy dt?
If x is increasing by 7 meters per second,
Okay,
and then it's asking how fast is y.
okay, at 7.5. Okay, guys, we look at number 10. This is very similar to the warm-up that we did today. You've got this graph, x times y. It's equal to 35. X times y is actually, actually, I guess it's y equals x over 35. I actually don't know what the picture looks like, unfortunately, but maybe something like that. And they're saying, hey, when you're traveling on this path, when you're at 7.5, what's your dy dt? Okay, well, let's look at this. We've got a picture. We know x, we know y. What's our equation going to be? Do you see that's the equation? Okay, now here's the tricky part. Here's what students do wrong. And so make sure you know this. There's one like this on your test. If I take the ddt of both sides, the number one thing students do wrong is when they take the derivative of this, they say this derivative is dx dt times dy dt. But that's actually wrong. What's the derivative of x times y? Think about it. What rule do I have to use there? It's product rule. So I have to use product rule here, which means it's the derivative of the first, and this is implicit differentiation. So what's the derivative of x? 1 times dx dt, because we're doing ddt. So 1 times dx dt times the second, which is y, plus what? The derivative of the second. So what's the derivative of y? Isn't that 1? But don't forget, dy dt times the first. And that's the hardest thing about this problem. Okay, when you have x times y, make sure you actually do implicit differentiation. But this is with d dt, so actually everything gets a little dt on it. Okay, let me make sure I did this right. Derivative of the first times the second plus derivative of the second times the first. All right, what's the derivative of 35? 0. And then they give me that dx dt is 7. So this is going to be 7y. But actually, now I can plug in a moment in time, right? So the moment in time, I knew that x is equal to 7 and y is equal to, I can't read my own handwriting. I think that's a 5. Okay, so y is equal to 5. So this is going to be dx dt, which is 7, times y, which is 5, plus dy dt, which I'm trying to find, times x, which is 7, is equal to 0. And so therefore, dy dt is equal to negative 35 over 7, which is negative 5. And negative signs, let me see. Yeah, I think that would be right. I'm getting negative 5. Anyway, if you get the wrong negative, just change it at the very end. Don't change it in the middle, though. You shouldn't be changing negative and positive signs in the middle. You can only change it at the end. And then I think this would just be units per second. Okay, so everybody get how to do these ones where they give you an equation, you just take the derivative of the equation. Let's go move to number 8. I think that's what Paige was asking. Okay, does anybody
Yes,
want to
ma'am.
call it out for me? What is
You want
this
me to
problem?
read it, Miss Shane?
Yeah, read it to me.
Okay. It's a conical tank with a height of 12 feet and a radius of 6 feet, and water is being drained at a rate of 6 feet cubed per second. And then it's asking for the rate of change of the water depth when the water's 3 feet.
When the water is what? When the height is
3 feet.
3 feet. Okay. Is everybody good on this setup? You've got a cone. You've got a radius, which is 6. You've got a height, which is 12. So this height is 12. Okay, this is I always think it's a metal cone. So, I mean, it might be plastic. I have no idea. But it's a metal cone. So the 6 and the 12 are not going to change. But the volume inside is going to change, right? So this level here, I'm going to call it H. Okay, H is going to change. All right, so think of what I've got. I've got a cone. I've got V. I've got H. What's my formula going to be? Okay, you guys know this formula, right? You have to actually memorize it for the test. You need to memorize this. You need to memorize the volume of a sphere, the area of a sphere, area of a triangle. Okay, so those are the common ones you need to memorize. This right here, you're going to have to do product rule. With a cone, you can do similar triangles. Guys, with a cylinder, like we just talked about, please do not do similar triangles. With a cylinder, replace the R with the number. Okay, but with a cone, what you have is 2 triangles here. You have a little triangle here. Okay, and this triangle changes. So this has an R and this has an H. And then you have a big triangle, which is 6 and 12. Okay, you do a little ratio thing going on. So you have R is to H as 6 is to 12. That's really 1/2. So R is to H as 1 is to 2. So if I solve for R, I'll get 1 fraction on the left, 1 fraction on the right, an equal sign in the middle. So actually 2R is equal to H. So that means R is equal to H over 2. Okay. I need to keep my H's, not my R's. So what I want to do is replace this R with H. Okay. If I know that R is equal to H over 2, I got this from similar triangles. Okay. What's R squared going to be equal to? Does anybody know? Are you guys good? It's H squared over 4, right? So I'm just replacing this R squared, okay? And what I did was I changed everything to H's. Now, why is that nice? Because this is really pi over 12 times H cubed. I'm going to leave the H cubed bounced out so that I can take the derivative more easily. The derivative of this is dv dt is equal to 3 pi times 3 times pi over 12, h, take the power down by 1, but don't forget dh dt. And at this point, I can just plug in. I know dv dt is negative 6. This is actually pi over 4. Do I know my h at a moment in time? They must have told me. It's 3 at a moment in time. This is 3 squared. I need to solve for dh dt. So this is negative 6 is equal to 9 pi over 4 dh dt. Okay, how do you solve for dh dt here? Will you multiply both sides by 4 times 9 pi? 4 over 9 pi, right? So I get dh dt is equal to negative 24 over 9 pi. Does that simplify any? I can divide by 3, so it's going to be negative 8 over 3 pi. Guys, do not bring the pi to the top. There's no reason that pi goes in the top. The pi's in the denominator. And that's my answer. I just need to know what h is, and I need to know what time is. H is a length, so that's feet, and I have a second for time. So this is feet per second, and that's my answer. You can check that page, see if my math, I like that.
Okay.